Hello everyone. In previous class, we had talked about question number 6 and question number 7. I would like to give a overview with these questions because yesterday very few of you were there in the second session. So we would like to go for the second session, the previous session of yesterday. So we'll have a look on question number 7 and question number 6 followed by question number 8. So in question number 6 said we have 2x plus 1 whole cube. We need to expand it using the identity a plus b whole cube. In identity a plus b whole cube, if we compare it with the 2x plus 1, instead of a we have 2x, instead of b we have 1. So we'll substitute the identity first over here. That is x plus y whole cube is x cube plus y cube plus 3xy x plus y. Now the value of x is 2x and value of y is 1. So while substituting the values, we'll get 2x plus 1 2x cube plus 1 cube plus 3 into 2x into 1 2x plus 1, that is 3xy or 3ab a plus b. Instead of a plus b we have 2x plus 1. Now 2x cube is 8x cube, 1 cube is 1 cube, 3 into 2 6x, 2x plus 1 inside the bracket. While multiplying this 6x inside the bracket, 6 2s are 12, x square and 6x into 1 6x. This 1 as it is and 8x cube as it is. We had rearranged the terms in the power of x, that is cubic power, then square, then 1 and then constant. Similarly in a minus b whole cube, we'll have a look on this question which is in the form of fraction. So we have x minus 2 by 3 y cube. X minus 2 by 3 y cube will apply the identity 2, that is x a minus b whole cube is a cube minus b cube minus 3ab a minus b. Here is the identity is x minus y whole cube is x cube minus y cube minus 3xy x minus y. While comparing it with the question x minus 2 by 3 y cube, here the question is x minus 2 by 3 y cube, we'll get x is equals to x only, and instead of y we have 2 by 3 y. So we'll substitute the values of x and y in the identity, that is x minus y whole cube, that is x minus 2 by 3 y cube is equals to x cube minus 2 by 3 y cube minus 3x into 2 by 3y x minus 2 by 3y. Now this 3 in the denominator and 3 in the numerator will get cancelled. We'll have x cube as it is, 2 by 3 whole cube, that is 2 cube is 8, 3 cube is 27, y cube. 3 and 3 get cancelled, we left with 2xy with negative sign, that is minus 2xy x minus 2 by 3y. Now this minus 2xy multiplied inside will give you minus 2x square y, and this minus 2xy multiplied inside 2 2s are 4, minus minus will become plus, 3 in the denominator xy into y, x as it is, y into y will become y square, x into x square, 2xy into x, that is minus 2x square y, x cube as it is minus 8 by 3 y cube as it is. You can leave the question here, or we can rearrange it as x cube first, then minus 2x square y, then 4xy square minus 8y cube in the powers of x. Now the seventh question is 99 whole cube. We can write 99 is 100 minus 1. So if we'll write 99 is 100 minus 1, we'll get 100 minus 1 cube. We'll apply the identity of a minus b whole cube here, that is a cube minus b cube minus 3ab a minus b. Instead of a we have 100, instead of b we have 1. It is 100 cube minus 1 cube, that is a cube minus b cube minus 3ab, 3 into 100 into 1, 100 minus 1. Now while substituting the values and calculating the answer, we'll get 970299. 970299 is the answer after substituting the values as 100, 1, 100 cube, that is 1000000 6 times 0 10 lakh. 1 cube is 1. 3 into 100 300, 100 minus 1 is 100 minus 1 as it is. This 10 lakh as it is, minus 1 as it is, 300 multiplied to 100 30,000, and 300 multiplied to minus 1, minus minus will become plus 1 and plus 300. This 300 and 100 10 lakh 300 30,001 will become minus 30,001. While subtracting, we'll get the answer as 9,70,299. Now, the next question is 100 plus 2 whole cube. 100 plus 2 whole cube will be 100 plus 2 whole cube. Will apply the identity of a plus b whole cube as a cube plus b cube plus 3ab a plus b. After substituting the identity, we'll have 100 cube, that is 10 leg again. 2 cube 8, 3 into 2 into 100, 600, 100 plus 2. 100 cube 10 lakh 8 as it is, 600 into 100 60,000, and 600 into 2 1200. After adding these four numbers, we'll get 10 lakh 61,208 as final answer. Now the last part of this question is 998. We'll substitute as 1000 minus 2. Again, we'll apply the identity of a minus b whole cube as a cube minus b cube minus 3ab a minus b. Instead of a, we'll substitute 1000. Instead of b, we'll substitute 2. After substituting the values, is a cube, that is 1000 cube minus 2 cube 8 cube 2 cube 8, 3 into 1000 into 2 6000, 1000 minus 2. Now 1000 cube is 169 times 0 minus 8, 3 into 2 6, 6 into 1000 6000, 1000 minus 2. After multiplying the 6000 inside 1000, after multiplying the 6000 inside the bracket, we'll get 10 19 times 0 minus 8, 6 lakh 60 lakh plus 600 into 6000 into 2 12,000. Now while adding this to positive and subtracting this to negative, we'll get 994011,992 as final answer. Now let's move on to question number 8. We need to factorize 8a cube plus b cube plus 12a square b plus 6ab square. Now we can see this 8a cube is perfect cube of 2, 8a cube. B is perfect square of b. Now 12a square b and 6ab square, we can write it as 3. We can take 6ab common from this 2 and left with 2a plus b. So this is 2a cube plus b cube plus 6ab into 2a plus b. This 6ab can be written as 3 into 2a into b. 3 into 2a into b. If we compare it with a cube plus b cube plus 3ab a plus b, this is nothing but a plus b whole cube. After applying the identity of a cube plus b cube plus 3ab a plus b is a plus b whole cube. So the factorized form of this is 2a plus b into 2a plus b into 2a plus b. 2a plus b into 2a plus b plus into 2a plus b, not 8a plus b Chirayu. It is 2a plus b because 8a is perfect cube of 2a. So it will be 2a plus b whole cube. Now the next question in front of us is 8a cube minus b cube minus 12a square b, this is a, 12a square b plus 6ab square. So again, this is nothing but the same question but different sign. We have 2 negative, 2 positive. This is nothing but 2a minus b whole cube. Let's have a look. This is 2a cube minus b cube minus 3 into 2a into b, 2a minus b. This is a cube minus b cube minus 3ab a minus b, that is 2a minus b, that is a minus b whole cube. Instead of a, we have 2a, and instead of b, we have b. So it is 2a minus b whole cube, that is 2a minus b, 2a minus b, and 2a minus b is the final answer of factorized form of the question given. Now the next question we have is 27 minus 125a cube minus 135a plus 225a square. 27 minus 125a cube minus 135a plus 225a square. So here we can identify here is 27 is perfect cube of 3. 125a is perfect cube of 5a. Very good, Aditya. Now this 135a, we can take 45a common, that is 3 into 3 into 5a, 3ab, 3 into 3 into 5a common, left with 3 minus 5a. So we have a cube minus b cube minus 3ab a minus b. This is nothing but 3 minus 5a whole cube. That is the answer is 3 minus 5a, 3 minus 5a, 3 minus 5a in the factorized form. Very good, Manan. Now the next question in front of us is 64a cube minus 27b cube minus 144a square b plus 108ab square. We need to factorize it. To factorize it, we'll find out the factors, that is perfect cube of first and second number. 64 is perfect cube of 4a, whereas 27b cube is perfect cube of 3b. that is 4a cube minus 3b cube. Next terms we will write 3 into 4a into 3b, that is 3ab, a minus b, that is 4a minus 3b. After multiplying we will get the same number. So 3 into 4a into 3b, 4a minus 3b, that is a cube minus b cube minus cab, a minus b. After applying this identity, that is a cube minus b cube minus 3ab, a minus b is equals to a minus b whole cube. We can write it as 4a minus 3b whole cube. That is factorized form 4a minus 3b, 4a minus 3b, and 4a minus 3b. 4a minus 3b in a bracket, then 4a minus 3b in another bracket, then 4a minus 3b in another bracket. This is 4a minus 3b whole cube is the factorized form for the question given. Good, Aditya Patidar. Now the next question we have is 27p cube minus 126 minus 9 by 2p square plus 1 by 4p. This is we need to identify the question, how we'll write it. So just have a look here. Is we have a question 27p cube. 27 is 3p whole cube. 1 by 216 is 1 by 6 whole cube. Now we'll simply write it as 3ab a minus b and we'll solve it and we'll get whether it is satisfying the equations or not. So we'll write 3ab, 3 into a into b, a minus b. This 3 and this 6 will get cancelled 2 times, that is 3p by 2. While multiplying this 3p into 3p, that is 9p square by 2. Yes, it is 9p square by 2. And there is 3p by 2 multiplied to 1 by 6. This 3 and 6 will again get cancelled. So we'll have 2 and 2, 4, p by 4. That is p by 4. So we have a cube minus b cube minus 3ab, a minus b. A cube minus b cube minus 3ab, a minus b is nothing but a minus b whole cube. That is 3p minus 1 by 6 whole cube using the identity a cube minus b cube minus 3ab, a minus b. We'll write it in 3 different brackets. In factorized form, it will be 3p minus 1 by 6, 3p minus 1 by 6, and 3p minus 1 by 6 in 3 different brackets. So the answer is 3p minus 1 by 6 whole cube. Good, Aditya Patidar wrote the answer very first, and then Geet Tiwari, you are also correct. Now we move on to the next question, that is question number 9. Very important identity from examination point of view, from questions point of view. We need to find the sum or difference of two perfect cube without actual calculation. If we need to find out the difference or sum of two perfect cube without actual calculation, we can apply this identity directly. So we'll have a look on question number 10 although to find out the factorized form or to find out the sums. We have question 9 part 1 is we need to verify x cube plus y cube is equals to x plus y into x square minus xy plus y square. This is into, not not subtraction sign, this is multiplication sign here. So this is x cube plus y cube is equals to x plus y into x square minus xy plus y square. What we'll do is we'll find out this using the identity either, or we can find it out by just multiplication. Although we know that x plus y whole cube is x cube plus y cube minus 3xy x plus y. We'll subtract this plus 3xy x plus y, will transport this towards left hand side. So after substituting this 3xy x plus y, after transporting this 3xy x plus y from right hand side to left hand side, it will become minus 3xy x plus y. Now we can see this x plus y is common in both the terms. So we can take x plus y common. We're left with x plus y square. This is a square minus 3xy is equals to x plus y whole square. We know that this x plus y whole square is nothing but x square plus y square plus 2xy and minus 3xy. Outside the bracket, this is minus 3xy. So while applying the identity of x plus y whole square, we'll get x square plus y square plus 2xy, and 2xy minus 3xy will give you minus xy. So we're left with x plus y, x square plus y square minus xy is equals to x cube plus y cube. Hence, verified. What else we can do it? We can use the right hand side. We'll multiply this x into the bracket, then y into the bracket, and we'll get x plus x cube plus y cube simply. Now the next identity is x minus y whole cube, and we need to prove that x cube minus y cube is equals to x minus y, x square plus y square minus xy. So this x minus y cube is x cube plus x cube minus y cube minus 3xy x minus y. As per the identity, we know that x minus y cube is equals to x cube minus y cube minus 3xy x minus y. We'll transport this minus x 3xy x minus y towards right hand side. That will give you x cube xy x minus y cube plus 3xy x minus y. Now this x minus y is common in both the terms. So we can take x minus y common in both the terms. After taking x minus y common, we're left with inside the bracket x minus y square plus 3xy. So while solving this x minus y square, we'll have x square plus y square minus 2xy plus 3xy. Now this minus 2xy plus 3xy, after solving this, we'll get xy. That is, inside the bracket we'll be having x square plus y square plus xy, and outside the bracket we'll have x minus y. Towards right hand side we have x cube minus y cube, that is hence proved. That is, x cube minus y cube is nothing but x minus y, x square plus y square plus xy, hence verified. Now the next question in front of us is question number 10. We need to factorize the sum of 2 perfect cube and difference of 2 perfect cube. So we have question 27y cube plus 125z cube. This 27y cube is 3y whole cube and 125y cube is 5z whole cube. So 27y cube is nothing but 3y whole cube and 125z cube is nothing but 5z whole cube. So we can write it as 3y whole cube plus 5z whole cube, and we know the identity, that is x cube plus y cube is x plus y, x square minus xy plus y square, that is 3y plus z, 3y plus 5z, that is x cube plus y cube is equals to x plus y, 3y plus yz, x square, that is 3y square minus xy, that is minus 3y into 5z plus 5z square. Now 3y plus yz is as it is. 3y whole square is 9y square, 5 3s are 15yz, and 5z square is 25z square. This is what this factorized form of the question given is. Now the second part says 64m cube minus 343n cube. So 64 is perfect cube of 4, whereas 343 is perfect cube of 7. We need to factorize it. It will be 4m cube minus 7n cube. So we apply the identity of a cube minus b cube, not a minus b whole cube. Point to be note. This is a cube minus b cube is equals to a minus b, a square plus ab plus b square. So we have the value of a, or value of x is 4m, value of y is 4n. We'll apply the identity mentioned here is a x cube minus y cube is equals to x minus y, x square plus xy plus y square. We'll substitute the value of x as 4m, substitute the value of y as 7n, x square 4m square, xy 4m into 7n, and y square 7n whole square. So we're left with 4m minus 7n, 4m square 16m square, 4 7s are 28mn, and 7n square 49n square. So this is the factorized form, that is 4m minus 7n, 16m square plus 28mn plus 7n square. So I got the correct answer from Aditya. Now the next question in front of us is question number 11. We need to factorize 27x cube plus y cube plus z cube minus 9xyz. Remember identity 8 mentioned in the NCERT book. The identity says a cube plus b cube plus c cube minus 3xyz is equals to x plus y plus z, x square plus y in the bracket, next bracket x square plus y square plus z square minus xy minus yz minus zx. This is also in the form of a cube plus b cube plus c cube minus 3xyz, 3abc. That is 27, x cube is nothing but 3x whole cube, y cube is y cube, z cube is z cube minus 3 into 3x into y into z will give you minus 9xyz. So we know the identity, or we can write this 3x cube plus y cube plus z cube minus 3 into 3x into y into z. Now we know the identity is x cube plus y cube plus z cube minus 3xyz is x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. We know that we have these values. So instead of x, we have 3x. Instead of y, we have y. Instead of z, we have z. So the value of x is 3x. Rest all values are same. So we substitute the values. X plus y plus z. This is a square. By mistake, it is typed or printed as cube. It is 3x square plus y square plus z square. 3x square plus y square plus z square. This is 3x square plus y square plus z square minus xy, that is minus minus 3x into y minus y into 2 minus z into 3x. So we'll substitute the values here as 3x square plus y square plus z square minus 3x into y minus y into z minus z into 3x. This is z. So this is 3x plus y plus z. 3x square is 9x square, y square is y square, plus z square is z square, minus 3xy is minus 3xy, y into z is yz, and 3 into zx, 3z into 3x will give you 3zx. So this is the factorized form: 3x plus y plus z, 9x square plus y square plus z square minus 3xy minus yz minus 3zx, so 3xz, one in the same thing. Very good, Prabgun and Aditya Patidar, you wrote the correct answer on chat box. Now the next question in front of us we have is, we need to verify this. X cube plus y cube plus z cube minus 3xyz is nothing but half of x plus y plus z. Next bracket, x minus y square plus y minus z square plus z minus x square. So the identity of a minus b whole square will help us out. That is, we'll take the right hand side of the question. That is half of x plus y plus z, x minus y square plus y minus z square plus z minus x square. We know that the identity of a minus b whole cube is a minus b whole square is a square plus b square minus 2ab, or a square minus 2ab plus b square irrespective of order. So it is half x plus y plus z, this is z, this 2 are z, x plus y plus z, then x minus y square is x square plus y square minus 2xy, y minus z square is y square plus z square minus 2yz, and z minus x square is z square plus x square minus 2zx. So after solving this, we'll get x square plus y square plus y square plus z square plus z square plus x square minus 2xy minus 2yz minus 2zx. If we'll add this, x square plus x square 2x square, y square plus y square 2y square, z square plus z square 2z square, 2xy 2yz 2zx. So we can take 2 common from this. That is half of x plus y plus z, 2 into x square plus y square plus z square minus xy minus yz minus zx. Now this 2 and 2 will get cancelled. 2 in the denominator and 2 in the numerator will get cancelled. So this 2 and this 2 get cancelled. We left with x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. This is nothing but the identity. We know that this is equals to x cube plus y cube plus z cube minus 3xyz, which is the left hand side of the question given, hence verified. After solving this, we'll get it as x cube plus y cube plus z cube minus 3xyz, which is LHS. Very good, Prabhu. Now question number 13. If x plus y plus z is equals to 0, very simple question. We need to prove x cube plus y cube plus z cube is equals to 3xyz. Since x plus y plus z is equals to 0, that is x plus y is equals to minus z, or x plus y whole cube is equals to minus z cube. After solving this, we'll get x cube plus y cube plus 3xy x plus y. So we'll apply the identity of a minus b whole cube here. That is a cube plus b cube plus 3ab a plus b. After solving this, we'll get x cube plus y cube plus 3xy, because x plus y is equals to minus z, we'll substitute as minus z. That is minus 3xyz is equals to minus z cube, or this minus z cube and 3xyz transposes from left hand side to right hand side and right hand side to left hand side. This will give you x cube plus y cube plus z cube is equals to 3xyz. Hence, if x plus y plus z is equals to 0, x cube plus y cube plus z cube is equals to 3xyz. Very simply, we can solve this question using this identity. We have identity x cube plus y cube plus z cube minus z is plus z cube minus 3xyz is equals to x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. We know that. So if we will substitute this x plus y plus z is equals to 0, that right hand side will become 0. This whole right hand side will become 0. Then x cube plus y cube plus z cube minus 3xyz is equals to 0. Just transport this 3xyz from left hand side to right hand side. This will give you x cube plus y cube plus z cube minus 3xyz is equals to 0. While transporting this minus 3xyz, we'll get x cube plus y cube plus z cube is equals to 3xyz. Hence verified. So this question, if comes in 1 mark, we can solve using the identity. If comes in 2 marks, we can solve in this way. And very simply, it is using the identity, we can solve it in 2 steps only. So move on to question number 14. Without actually calculation, find out the cube. Or without actually calculating the cube, find out the value of minus 12 cube plus 7 cube plus 5 cube. We are not supposed to find out the cube of 12, 7 and 5. That is, we don't need to calculate 12 cube is 1728, 7 cube is 343, or 5 cube is 125. Without actual calculation, what we need to do is we need to find the value of a cube plus b cube plus c cube. Just have a look on the question. This is 7, this is 5, 7 plus 5 is 12, and 12 minus 12 is 0. That is, if x is equals to minus 12, y is equals to 7, and z is equals to 5, we have x plus y plus z is 0. In case if x plus y plus z is 0, then x cube plus y cube plus z cube is nothing but 3xyz. That is, 3xyz will substitute the values of 3xyz as 3 into minus 12 into 7 into 5. While multiplying, we'll get 3 into minus 420, that is minus 1260. Yes, you are correct, Prabhun. Now, the second one is minus 28 cube minus 15 cube minus 13 cube. Here again, we have a cube plus b cube plus c cube, and value of a plus b plus c or x plus y plus z is 28 minus 15 minus 13. Minus 15 minus 13 will give you 0. So the answer will become 0. A plus b plus c or x plus y plus z becomes 0. If x plus y plus z is 0, the value of x cube plus y cube plus z cube is equals to 3xyz. Before a couple of minutes, we have discussed the same. So x cube plus y cube plus z cube is equals to 3xyz. We substitute the value 3 into x into y into z. These two are negative. So negative into negative will become positive. 15 into 13 into 28 will give you 5460 positive into 3. The final answer is 16380. I got the answer from 3 of you. That is Prabgun, Aditya and Alak wrote the right answer. That is 16380. Now the last two questions, 15 and 16, give possible expressions for length, breadth and height, length and breadth of each of the following cases. So we have 25a square minus 35a plus 12. What we are supposed to do is we need to factorize this. If it is in the quadratic form or the square form, the highest power, highest degree is 2, will get the two factors. One of them could be the length and another will be the height, if this represents the area. So area is equals to 25a square minus 35a plus 12. We need to find out the length, possible expression for length and breadth. So what we'll do is we'll factorize it, because area of rectangle is nothing but length into breadth. So we'll have this as 25a square. This 35a we can write it as 20a and 15a and plus 12, because 25 into 12 will give you 300 and 20 into 15 is again 300. So what we did is we did the middle term splitting. Now we'll take 5a common from first two terms, left with 5a minus 4, and minus 3 common from first two terms, we'll left with 5a minus 4. Now we can take 5a minus 4 common. This will give you 5a minus 4 into 5a minus 3, 5a minus 4 into 5a minus 3. That is possible expression for length and breadth are 5a minus 3, 5a minus 4. So length could be 5a minus 3, breadth could be 5a minus 4. If length is 5a minus 3, breadth will be 5a minus 4. If length is 5a minus 4, breadth will be 5a minus 3, irrespective of order again. Now, the second part of the question is 35y square plus 13y minus 12. 35y square plus 13y minus 12. Again, we'll do the middle term splitting. Middle term splitting, 35 into 12 will give you 350 plus 70, that is 420. And 28 15s is again 420. So we'll split it as 28y minus 15y. Applying middle term splitting, we'll take 7y common from first two terms. If we'll take 7y common from first two terms, we'll left with 5m plus 4. And if we'll take minus 3 common from last two terms, that is again 5y plus 4. We can take 5y plus 4 common, we'll left with 7y minus 4. So the possible length and breadth are 7y minus 4, 7y minus 3, 5a plus 4, or 5a plus 4, 7y minus 3. That is, if length is equals to 7y minus 3, breadth will be 5y plus 4, or if length is equals to 5y plus 4, breadth will be 7y minus 3. So we have length and breadth are in this form, 7y minus 3 and 5y plus 4. Very good, Akhilesh, Prabgun, Ishan. So we have next question. We need to write the possible expressions for the dimensions of volume. That is, volume is given in the form of 3x square minus 12x. 3x square minus 12x. We need to split it in three different numbers or three different algebraic expressions. So while getting it, just have a look on the first question. We can take 3x square minus 12x. We can take 3 common. Even we can take x common. So if we'll take 3 common, we'll left with x square minus 4x. Again, we can take x common. So this is x, the middle one is x. That is 3 into x minus 4. 3 into x minus 4. 3 into x minus 4 are the possible length, breadth and height, possible length and breadth and height for this question. That is 3x square minus 12x will be 3 into x minus 4. So this is 3x and x minus 4. The possible dimensions of the cuboid are 3x and x minus 4, that is length, breadth and height respectively, irrespective of order. That is a possible length, breadth and height could be anything 3x, x minus 4, x, 3, x minus 4, or x minus 4, 3 and x. We can have the factorial 3, there is 6 possible arrangement for the C. The length, breadth and height could be 3x and x minus 4. Now the last question, last part of the question says 12ky square plus 8ky minus 20k. Check me the answer. Okay, the second one you wrote the answer, Akhilesh and Prabgun. The answer you wrote is 4k, 3y plus 4, 3y plus 5 and y minus 1. Whereas Ishan wrote is 3k, 2k, k minus 5k. Again we need to do this middle term splitting here. First we'll take the k common. So while taking the 4k common, we can take 4k common. 4k common, we left with 3y square plus 2y minus 5. 3y square plus 2y minus 5. This is the quadratic equation. We can again split the middle term. After splitting the middle term, we'll get 3y square minus 3y plus 5y minus 5. That is 5 3s are 15 and 5 minus 3 will give you plus 2. So we can take 3y common from the first two terms, left with y minus 1, and 5 common from the last two terms, left with y minus 1 again. So after taking y minus 1 common, we left with 3y plus 5. That is the possible expressions are 4k, 3y plus 5 and y minus 1. 4k, 3y plus 5 and y minus 1. This is the possible dimensions of cuboids are 4k, 3y plus 5 and y minus 1. Why we cannot be able to leave it here only? Because we have three different numbers, 4k and 3y square plus 2y minus 5. So we have one number here, one expression here, and one is here. Why we cannot be considered this as length, this as breadth, and this as height? The reason behind the same is because the length, breadth, or height are one dimension quantity. We cannot be able to have them in square form. The square is area. So we'll further split it and we'll get it in single dimension, that is in the linear form, that the power must be 1. So here the power is 1, here is power is 1, and here the exponential value of k is 1. So y raised to power 1, y raised to power 1, and k raised to power 1. These are the three different expression for length, breadth, and height. So we are done with the chapter polynomial now. Tomorrow we'll be discussing about the solutions of further extra questions. That's all for the day. Thank you very much.